Lukman Hussain. Can you please confirm if you are there?
No, he is absent.
Okay. So I would like to move to our next speaker, Miss Jusubikova Aizada. So are you there? Can you please confirm?
Not also there.
Okay, I will move to Mr. Prakash Singh Thapa. So are you there?
Yes, sir. Yeah, I am.
Okay, let me introduce briefly Mr. Prakash Singh Thapa. He is Under Secretary, Department of Forest and Soil Conservation, Ministry of Forest and Environment, based in Kathmandu, Nepal. Over to you, Prakash ji, please.
Thank you, sir.
फोटो लो गया तो मैंने तुमको बोला है ना, तुम कहाँ रहते हो यार? मैंने तुमको बोला कि 2 बार, तीसरी बार बोला हूँ। किसी का सेशन एंड हो तो तुम्हें यहाँ रहना चाहिए।
Hasrat, can you please unmute yourself?
I'm sorry, extremely sorry. Yes.
So Prakash ji, we can see your slides. Please go ahead.
Okay, thank you, sir. Honorable Chair, Co-Chair, and all the esteemed participants from the different countries across the world. So today I'm going to share some of the experiences that we intervened during our piloted project in Nepalese Himalaya. I am not exactly the academician, so I'm practitioner. So my presentation style will be a bit different than other academicians. Please tolerate with me. Actually, Nepal is blessed with the beauty of mountains, water towers, and different natural resources. But at the same time, we are suffering from different kind of natural as well as artificial hazards. Hazards such as we can say floods, landslides, earthquakes are very common in Nepalese Himalaya. As we all know that Nepal lies in between Indian tectonic plate as well as in between the Tibetan plate, and these two plates are colliding each other, releasing some energy or stress, causing different vibrations in the form of earthquake. At the same time, the geology of the country is also very fragile, young, and weak. At the same time, the impact of this changing climate change is heavily prevalent in the country in the form of increasing temperature and the torrential rainfall, cloud burst. Yesterday and today, many our esteemed guest has presented about the condition of the world, including Nepal. So Nepal is also not very far away from these impact of climate change and natural hazard, and suffering from different kind of problem at the moment. Nepal is developing country at the same time, and here is a lot of construction of the infrastructure in the form of the rural roads, and the road construction is without any particular engineering norms. They are following the dozer technology at the moment. So different kind of disasters are invited by the people of this nation as well. So today in our presentation, I will be more focusing on the landslide and how we treated these landslide, considering both structural and non-structural methods. And some technology are piloted in the country. So this could be important for some of the regions in South Asia having similar geological setting. Let me move to next slide. And so as already mentioned by Dr. Dan, also there are two different methods to treat these landslide disaster, such as structural and non-structural measures. In structural measures, generally we put some retaining walls, bioengineering technology to control or to prevent further landsliding in particular zone. But in case of non-structural measures, we apply capacity building, community awareness, at the same time some monitoring system or early warning system in that particular landslide or particular disaster. So I'm going to briefly explain about where we implemented these both structural and non-structural measures to treat the landslide. I'm not reading all those things, but here we can see these are the sites where we implemented new technology of early warning system for the landslide. At the same time, some structural interventions were implemented. Okay, this is one site. This is Nuwakot district of Nepal, where we selected one landslide after the mega earthquake of 2015 in Nepal. So in this photo, we can see that this whole region suffered from the mass movement. In the lower side, we can see there are gullies formed, and this whole region started sliding after the 2015 earthquake. So this micro watershed has been selected for this study. Another one is in Dolakha district, which one is another epicenter or after the Gorkha earthquake. So these two districts were selected for piloting the new technology. So I will explain very briefly how we conducted different treatment. For this, we used locally available material and with the participation of the local people, so that the sustainability of these technology would retain within the villagers. So with the help of local people, we divided this whole landslide in the different zones, so that accordingly we can put different kind of interventions in different zones based on slope, drainage, and site moisture. So we used simply three indicators for the zonation of these landslide. And after zonation, we discussed about what kind of structural measures can be implemented in those areas. This is one example from one of the landslide in Nuwakot, where we after the zonation, we discussed with the local people and find out different kind of treatment activities for this landslide. After that, we started vegetative treatment. This is one, we can say, the structural treatment, and these are some of the structural treatment we can see in the photographs as well, like watling. The bamboo that are locally available in the local area, we use that as a watling for the treatment of landslide. Similarly, these loose stone masonry with some special kind of structure. Then these are the jute netting with peanut grass for the treatment of these landslide. This is also bamboo watling in the landslide area, we can see here. So these are the locally available stones for the water diversion channel, for preparing the water channels. And the involvement of local people can be seen here. They themselves helped or participated for the treatment of these landslides, and they are taking the ownership of this all technology. Now let's move to the non-structural treatment. What we conducted there are the two things. First, we developed the awareness about the landslide, and then capacity building of the local people for preparing these different kind of structures and for knowing about this landslide early warning system as well. I will briefly describe what is this landslide early warning system. In the early warning system, what we prepared is we try to measure three data from the local area. One is precipitation, another one is soil moisture, and the third one is displacement. And if any displacement happens in the area, then we try to record that one. So for this, we selected one of the stabilized site above or in the surrounding area of that landslide, where we installed our this DCP, data collection platform. This one is the central one, where all the data, whatever the rainfall occurred in the area, that was measured and sent to the to this platform. Another one is this soil moisture sensor. Soil moisture that can record at the 30 centimeter and 50 centimeter below the ground were set in this area. Similarly, the third equipment were 4 extensometers. They measure the displacement in the lower side of this landslide. So in this way, we recorded these 3 parameters. We set threshold, how much rainfall or soil moisture or extensometer recording can be taken as threshold was done based on the literature review, and we have set some threshold for this particular region. Based on that, if any of the reading or any of the data exceeds that particular threshold, then this instrument starts sending its SMS to the local people, SMS to the main server in Kathmandu, and based on that, we can send them alarm. So we set three types of alarm. First one is just to prepare themselves that something is happening in the area. Then the second alarm was for the preparation time, so that they can put their main essential things together in their own bag or something. And then the third alarm is just move to the safest area or evacuation centers. So based on this formula, we prepared this landslide early warning system. So other things are same, but for the measurement of land displacement, in this way we prepared 3 or 4 pegging system based on the length of this landslide. So if anything happens within these 4 sections in the form of cracking or displacement, then it will be measured in the main DCP or data collection platform. These are the instruments used for the collection or monitoring of the landslide. This is actually the landslide crown part, and this is little bit established area initially. The downside, we can see the settlement, and they are the very poor and ethnic people. They are living with the disaster, and below the landslide area is some agricultural land as well. The earlier picture is from the Dolkhar, Nepal, and the second one is from the Nuakot, Nepal. Yes. So these are the equipments used for this system. Very simple kind of system, nothing complicated. We can use this one with the community people. We hired one local person as a record keeping person also. So this is simple system that if anything happens in the area, then this will be recorded by data logger, as well as it can be seen in the display board. Then they will send this thing to community leader, and at the same time the siren system is also there. And this SMS has been sent to 10 people to the who are nearby the area, and at the district level and the central level also, who can rescue if anything happens in the area. So there is some learning from the area. This system uses simply the extensometer, soil moisture sensor, and the rain gauge, and the SMS is sent to the caretaker's mobile every day. That caretaker has also responsibility to record all the database if anything is happening in the area or not, using that particular DCP data collection platform. And as I have already mentioned about these siren system, there is first siren, second siren, and third siren, or the final siren, which will help people to go to the safest area accordingly. These are the threshold maintained for that particular landslide early warning system. So if the rainfall is 60 mm per hour or more, then the siren will blow. Similarly, soil moisture is kept near about 70%. This can measure the movement of 12 inch or 1 feet. If any crack formation happens beyond this 1 feet or 12 inch, then it can record that thing and send to the server, central server. And a siren type, at that time we used a single siren. There is one event happened in the Mehle landslide of the Dolkhar district. On the 22nd August 2018, there was again landslide occurred in Dolkhar district, where what happened at that time, we saw what is the monitoring status of our instrument, and the rainfall exceeded the given limit, provided limit, and similarly the moisture content was high at that time, and the displacement was also recorded. And at that time we found that local people heard the siren, and they came out of their house, and some family vulnerable at the moment were safe at that time, and they were happy with their siren system. So in this way, we can save the life of people. At the same time, we have to spread the awareness, and we have to improve the capacity of the local people. Sometimes it can make some false alarming system in the area. So there is some certain kind of learning we gained from that area, that this landslide early warning system is very much important for the landslide risk minimization. However, this can provide a kind of false sense of security, that people will just uh, stay inside their homes saying that, okay, this will save our life, but that never happens, because landslide can come at any time. So this can give a false sense of security. At the same time, it should be taken as an aided tool, not the kind of silver bullet for the landslide, but we can take it as an aided tool for the landslide management. Similarly, this siren system should be multiple, because the learning from the area was that after the earthquake, all the local people do have their roofing system with this galvanized what we call roofing system. So when the rainfall occurred, the sound made by the roofing system itself disturbed that siren. So only one way siren system is not very good. So now we recommended multiple siren system in two direction at least, so that some other people can listen that siren is ringing or not. At the same time, this instrument installation site should be stable. Based on the hazard mapping, we can find out which site is very stable, and maintenance and technical backstopping is very much necessary. And the involvement of this local committee is always important and sustainable. So on both the sides, we used very low cost technology for this early warning system. And at that time in the 2018, it was installed only with the help of this much amount, 5,000 US dollar or 5 lakhs Nepalese rupees. Now the cost has been increased slowly, but we can install it within the range of this much. So we need to replicate this kind of technology throughout this Himalayan region, as Nepal represent almost 85% of slopy land area in the country, and landslide is the on the top of the rank for the different kind of disasters in context of Nepal. So we need to use this kind of technology throughout the country, and of course we can replicate in another parts of the world as well. But on addition to this, I would like to say that now we are advancing this technology with some digital sensors, and now we are trying to conduct some real-time technology, which is more advanced than this one, and which gives us a real-time data scenario for every day, every time. Now we have piloted another site in Nepal, and next year we are trying for next two sites. So this is still in the piloting stage. So we are combining this together with these different bioengineering techniques. I think in future we can make certain scenario or certain findings based on these different piloted sites. This much is from my side. Thank you so much for listening me and providing this opportunity. Thank you so much.
Thank you so much, Prakash ji. Very important and viable solution you presented. I can understand fully because couple of weeks before I was in Sindhupalchok, very landslide prone area. I know the importance of this solution. Very viable. Thank you so much.
Thank you, sir.
Our next speaker is Dr. Simona Spanu. Can you please confirm if you are there?